Good morning, everyone. My name is Vishnu Dhanda, and today I'm going to be presenting on the implementation of a communication protocol for additive manufacturing using a 6-axis robot. What is additive manufacturing? This is the process in which material is deposited layer by layer to create a part. Why do we use it? We can create things really quickly, so rapid prototyping, and we can manufacture these really complex geometries, which previously would not be possible using traditional machining techniques, such as milling and turning. And finally, it's a much lower cost. Additive manufacturing of continuous fiber reinforced composites is what we deal with at the Laboratory of Engineering Materials. What is a composite? It's a combination of two materials with different physical and chemical properties to create these really advanced materials which incorporate all of these properties. We deal with carbon fiber polymer composites. So these are essentially carbon fibers which are enclosed in a polymer matrix. Applications of these materials include automotive and sports. So a lot of Formula One cars have composite parts. Aerospace, a lot of rockets and aircrafts use composite parts, and finally biomedical applications, so you can make things like prosthetics and knee braces. Traditional manufacturing methods involve the use of weaves, which are essentially fabrics of carbon fiber, and molds, which what you do is you take these fabrics and put them in these molds to allow them to set. In composite materials, the strength is dependent on the orientation of the fiber. So the direction in which your fiber lies is where your strength is. Using these weaves doesn't allow us to tailor these directions, these fiber orientations, and therefore not creating the highest strength to weight ratio part. So advanced additive manufacturing technique is needed. So using additive manufacturing of 6-axis or with a 6-axis robot, you can tailor the fiber placement to create these really high strength parts, which were previously not possible. But a couple of problems arise. First of all, you need a printhead capable of 3D printing carbon fiber. The next thing you need is software, which to determine the print path and the robotic movement. And finally, you need software to synchronize the actions of the printhead and the robot. So to solve this problem, a custom printhead was developed using by the Capstone Group in collaboration with the Laboratory of Engineering Materials. And this printhead is capable of cutting the fiber after a layer is complete and also getting to the temperature required for the carbon fiber extrusion. Finally, the software was developed. There are two pieces of software which are developed. The software to define the custom parts for extrusion and the robotic movement, and communication software, which was developed to enable the ABB robot to communicate with the custom printhead setup. So some of the communication software capabilities is that once the nozzle gets to temperature, it lets the robot know that, oh, you can begin the movement. And once the movement begins, the robot lets the extruder know that you can begin extruding this carbon fiber enclosed in the polymer. If there's ever a jam detected, the printhead will literally let the robot know that, oh, there's a jam, please stop. And finally, there's a cutting mechanism. So after each layer, the robot tells the printhead that layer is complete, and now you can do a cut. To make the software, we used an open source API from the Duet 3D boards. And we also created a custom API to program the ABB robots. Our final results, you can create the geometries which previously would not be possible. So I have some pictures of the geometries we're able to create. So you can tailor the fiber placement, and now you can create these really high strengths to weight ratio parts, which previously in traditional manufacturing techniques would not be possible. Some acknowledgements. I would like to thank the Laboratory of Engineering Materials, the Capstone Group, and the Schulich School of Engineering undergraduate program. If there are any questions, please let me know. My contact information is on the screen. Thank you.